right, guys. Hey, welcome back to another lesson. Today we're going to talk about slopes of lines. And maybe this sounds a little familiar because he talked about slopes in Algebra 1. So how does that incorporate in geometry? I'm so glad you asked. Okay, this is going to be a two-part lesson. The first part we'll talk about slopes, and then we'll talk about what parallel and perpendicular line slopes are. Okay, we'll get into that. And then for part 2 of the video, we'll start talking about, now we know what the slopes are, and we can compare them, how can we create an equation that's parallel or perpendicular to a line? Okay, so stay tuned for that. First question, have you seen this sign before? Maybe, depends on where you live, right? Might not be a common or popular sign, but a lot of times people say, well, Mr. McCullough, that's a 10% slope. That's what it's telling me. And I'd be like, yeah, you're right. But what does 10% actually mean for a slope? Always good questions I'm asking, right? 10% as a fraction is 10 out of 100, right? Or 1/10, either way. And I know what slope is to start, right? Isn't slope how far you're rising over how far you're running? That's usually how it's described, right? Changes of y's over changes of x's when it comes to an xy plane. So over here, I'm rising and running a little bit differently on that slope. So for this guy, I am changing vertically by 10 feet. For every 100 feet, I travel horizontally. That's what that 10% is telling me. So I'm going up by 10 or downhill by 10%, right? By 10 feet, I'm sorry. For every 100 feet, I travel vertically, not or horizontally. Getting that switched in my head already. Now let's think about it this way. Let's say you're a truck driver and you're carrying a bunch of weight and you see a sign that says, hey, 10% slope gradient. You're probably going to slow down a little bit, right? With all that weight, that's a lot of force to stop if anything should happen on that hillside. So 10%, maybe not the biggest slope, okay, but it does have some effect on your speed and stopping ability when it comes to brakes. Now, if I were to change this, let's make it 40%. Okay. Given what this is, 40% is probably telling me that it's going to be a lot steeper. And if I'm going downhill, then I am falling 40 feet vertically. For every 100 feet, I travel horizontally. Okay? And that's probably going to definitely increase my speed a lot more than 10%, right? I don't know if you've been skiing before, but ski slopes do have some sort of slope gradient to it. Okay, depending on your ability level. If you're a beginner, you're going to start at a very, very low slope gradient. If you're more of an expert, then yeah, you're going to be able to handle the higher slope gradients because you know what to do. And it's a lot faster, so you better know what you're doing, right? Okay, so just a little example of what slopes are out in the real world. A lot more examples out there, but that just kind of gives you just something to think about. Okay? Okay. So now what we're going to do is look at just a real quick algebra flashback. Okay? This was the formula for slope, and there's someone at the door. Give me one moment. Just one moment. Just ponder on that. All right, sorry about that. I'm back. Did you miss me? I hope you said yes. So if it's rise over run, I'm changing my y's over change of x's. The subscripts just tell me what point I'm looking at. Okay, it does have nothing to do with the calculation. So for instance, okay, if I had 2 points like this, I can name the first point as x1, y1, and the second point is x2, y2. Okay? And it doesn't matter the order. It doesn't matter what direction I'm heading in. The slope's going to be the same for it. Okay? All right, so what we're going to do, just for one example, and I don't need the PowerPoint anymore for right now. Go. Maybe for part 2 I might need it. So let me just exit out of this. There we go. Okay. That way I can see the camera and I can see how much space I have. There we go. So what we're going to do is I'm going to give you 2 points, and we're going to calculate its slope. Okay? So one of the points is 6, -2. The other point would be -3, -5. Okay? And I'm going to figure out how far did I travel from here to here in a y and x direction. That's what slope is, essentially. So let's go ahead and figure this out. Here's the formula. Okay, we're just going to subtract the y's, subtract the x's. If you would like to, you could label, and no reason why, but if this is my first point, that's x1, y1. If this is my second point, that'd be x2, y2. I'll just move the camera up just a little bit. I think it cut it off, just so I had to change it. Okay, in the numerator, I'll subtract the y's, -5 minus a -2. And then in the denominator, I'll subtract the x's, -3 minus 6. Can you see where we might have some issues? Negative signs, right? Oh, they're a killer. But you have to be careful, okay? You have to make sure that you're including all those little negative signs. Now in the numerator, I'm subtracting a negative, okay? So that means I'll be adding 2. So -5 plus 2 gives me a -3. And for the denominator, -3 minus 9, -3 minus 6 is a -9. I'm not quite done yet, all right? If I could reduce, I want to reduce. So this becomes a positive number because we have negative divided by negative, okay? And then what I can also do is reduce it. 3 can go into both of them. 3 can go into 3 once. 3 can go into 9 3 times. Okay? So my slope for this guy would be 1/3. Let's put some English to this, okay? 1/3 as a slope. So that means I'm going to rise by 1 unit, and I'm going to run 3 units. Okay? So rise means I'm going to go up 1 unit because it's positive. The bottom part's positive, and that means I'm going to go in the right direction by 3 units. Okay? So on a graph, that'd be what? Going up by, if I want to go from here to here, you're going to go up 1 over 3. That's my change. You can kind of relate this to translations, right? Remember how we did translations in a previous lesson? That's what we're doing here. All right. What do you think? Not too bad. Hopefully that's kind of like a review. Now the algebra, or not the algebra, now the geometry part. Let's talk about what parallel and perpendicular lines are doing. And I'm going to try and keep this board visible a little bit. And if you need more examples, I do have more examples in my notes. Okay, if you need some more practice with that. Okay. Now, parallel and perpendicular. Some characteristics on these guys. Okay. If lines are parallel, we know that they don't intersect. Right? They intersect and not parallel. That's the whole definition behind it. For them not to intersect, they have to be rising and running in the same direction, to be side by side to one another. So what I can say is that these guys have the same slope. Okay? Same slope. So if this had a slope of 3, this has a slope of 3. If this had a slope of 1/5, this has a slope of 1/5, and so forth. There is a difference, though. Do you see the difference? They have what? Different y-intercepts. Remember, our y-intercept for a graph is like our starting point, and we'll discuss more of that in the second video. So I have the same slope, but different y-intercepts. All right. Characteristics of parallel lines. Okay. Now, over here, perpendicular, we know that perpendicular lines have a big characteristic, and that characteristic is they create a right angle. Okay? Now, let's think about the slopes for a second. If they intersect, they can't be the same slope, huh? So you have different slopes. Now, one could argue what that difference is. For them to intersect, one of the slopes has to be positive and one of them has to be negative. So the slopes have to be opposites of each other, huh? They have to be an opposite. Meaning what? The signs have to be different. That's what that means. Now, what else? Because here's the deal. If the slopes are opposite, that doesn't mean anything because I could draw two lines that intersect that don't create a right angle. So how do we get that right angle? Well, we need to take the slope of one of these lines and find the reciprocal of it. That will give me that 90-degree angle. So it would be opposite reciprocal. Okay? Now, let's talk about reciprocal. If I have a number that's 1/3, its reciprocal, if I flip it, will become 3/1. That's what reciprocals mean. So another example would be like 4/5. The reciprocal would be taking 4/5 and flipping it. It would be 5/4 for that guy. Okay? Now, let's include the term opposite. So opposite means the signs change. So if this was negative, the opposite reciprocal would be a positive. If this was positive, the opposite reciprocal would be negative. The signs would change for that guy. So if these are my slopes for both lines, this is a characteristic of perpendicular lines. Okay? Just like that. Could they have the same y-intercept? Why not? I could create another line that goes right through this point here and still make it 90 degrees, right? Parallel lines, I can't do that because they're not allowed to intersect. But I could intersect at the same point on the y-axis. So I don't have to worry about that criteria. Here, the only thing we have to worry about is, are the slopes opposite reciprocals? Okay, does that make sense? Let's do a couple examples with it. All right. Bringing this board all the way over, and can we still see? Yeah, we can still see that. Okay. Let's do an example. Here we go. All right. Now, I would like to figure out if these lines, line AB and line CD, are they parallel, perpendicular, or neither of them? Okay. Parallel is the double bar, right? We'll just use the symbol. Perpendicular is the upside down T, or neither. One of those three options. Now notice, I don't actually have the equations for the lines. We'll talk about that later. I just have points that are on each line, okay? What I'm going to do, since I know that the slopes can predict this, I'm going to calculate the slope for each line and make a comparison, okay? So what I'm going to do is I'm going to write M for slope, right? And then AB I'm going to put as a subscript. That way I know that this slope belongs to line AB. The formula, if you remember, subtract the y's over subtracting the x's. If you want to label? You can. This could be my first x coordinate, first y coordinate. This could be the second x coordinate, the second y coordinate. And it doesn't matter, guys. When I switch these, I'm going to get the same slope. Okay? So I don't want you to feel like you did something incorrectly if you went a different direction with subtracting. Subtract these guys. So it'd be 0 minus 13. Subtract the x's, negative 11 minus 14. Be careful with negatives. Simplify. At the top, we get 0 minus 13, negative 13. Negative 11 minus 14 would be negative 25. For my last step, I want to simplify if I can. 13 over 25 can't reduce, but the two negatives are going to cancel out, right? Negative divided by negative gives me a positive. My slope for AB is 13 over 25. What that means is I'm rising by 13 units, and I am going to run, remember that means up, and I'm going to run 25 units to the right to get to that next point on the line. Okay? So far, so good? Yeah? Okay. Now, we have this in place. Let's go ahead and find the slope for CD. So M for slope, I'll put CD as a subscript, just so I know that that's what we're looking for. It's this line. I'm going to label my points. There's the first set of coordinates. Here are the second. Okay. In the numerator, I'm going to subtract the y's. Negative 5 minus 7. And the denominator, I'm going to subtract the x's. Negative 4, minus a negative 3. Just like that. In the numerator, we have negative 12. I'm subtracting a negative, which is like we're adding, right? Negative 4 plus 3, which gives me a negative 1. I could simplify that. It becomes 12 over 1. The two negatives cancel out, makes it a positive. And this will be my slope. Let's make that comparison. Ready? Let me just bring this over. Okay. First off, are these guys parallel? No. They are not identical slopes. They're not parallel. Are they opposite reciprocals? All right. Let's break the word down. Opposites. Is one positive and one negative? No. Are they reciprocals? Meaning, if I take this number and flip it, do I get this number? No. So therefore, it's neither. These guys are not parallel. They're not perpendicular. They're just intersecting lines. That's all they are. Okay. Could you graph both lines to conclude that? Absolutely. Okay, and I encourage you, graph the lines. Make sure that you're coming up with the same answer. Okay? All right, what do you think? Want to try one more? One more example? Why not? I think that would be a great idea to do one more example. All right, here we go. A is going to be at 3, 6. Point B is at negative 9, 2. So this is line AB. Now for line CD, we have negative 3, 7. D is negative 4, negative 5. Okay? Now I want to figure out, I'm sorry. There we go. I want to figure out if these two lines are parallel, perpendicular, or neither. Remember, I'm just giving you the points that are on each line, but that's enough information. All I need is the slopes. Okay, once again, go ahead. I'm going to mark both of them just to save some time. And speaking of time, I think we're up to, 19 minutes already. Time flies. Okay, in the numerator, we have 2 minus 6. Denominator, negative 9 minus 3. simplify each part. In the numerator, we get -4, and then we get a -12 in the denominator. Now, two things. First, the negatives cancel out, it becomes a positive number. 4 over 12 could reduce. 4 goes into both of these guys, it becomes 1/3. Okay, that's the slope. Now, could you still say that 4 over 12 is the slope? Absolutely. There's nothing wrong with that. Reducing it is a benefit. You'll see why in this one. Subtract, we get -5 minus 7. Wait a minute. Ah! Did you catch it? I just wrote the same thing from the last problem. Oops. This would be 5, 4, 2, 3. Why didn't you tell me that that was incorrect? Look at all that time I wasted. You should have told me. All right. I'll forgive you this time. Subtract the y's. We have 3 minus 4, and then 2 minus 5 in the denominator. Numerator, we get -1. And the denominator, we get what? -3. Simplify, we have a negative in the numerator and denominator. It makes us a positive number. Now, let's compare. Okay? Looking at my options over here, are they parallel? Do they have the same slope? 1/3 and 1/3? They do. These guys are parallel lines. Okay? Not too bad. Now, if they were perpendicular, okay, then this would have to be a negative number, because that's positive, and then I'd have to take the reciprocal, which would be flipping this. This would make it perpendicular. Okay? Now, it's not. I just, for an example, so that way you know what that would look like in the end, okay? I just changed it temporarily. I don't want you to be confused by that. All right. So that's it. So we did one example of how to calculate slope. Then we had 2 examples of how to compare them. One final thing, okay? I promise, this is it. Can we get through 2 examples? Just 2? Please, 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 please. Okay? What if I gave you the equations of the line? Ah. What if I did that instead? Well, let's figure out what that's going to look like. Let's say I gave you these 2 equations, okay? And I want you to figure out, are these 2 lines parallel, perpendicular, or neither? Now, you could graph it, which would help. Unfortunately, though, with perpendicular, it's hard to tell because you need to make sure there's a 90-degree angle being formed. So graphing could maybe get you to that confidence that, yeah, this is what I think it is. But what we're going to do is compare slopes. Now, if you recall, way long ago in your Algebra 1 days, that slope-intercept form is y equals mx plus b. Your m is your slope, right? And b was your y-intercept. Look at this first equation. It's written in slope-intercept form, but the second equation's not. I can't compare these 2 yet. I can't compare them. They're in different formats. Okay? So what I have to do is take this guy and change it to this, and then compare them. Let's go ahead and do that. By the way, this is standard form, if you didn't know. I'm going to solve this guy for y, because this is good. I like this equation. So over here, I'm going to subtract 4x to both sides. That cancels. 3y equals 6 minus 4x. I'm going to do one thing. I'm going to flip this. Okay? See how this is still the same thing? I didn't change it, the actual values. This is still negative, right? This is still positive. The reason why I flipped it is because you see how the x's are always first? It's a lot easier to compare if we keep it in that format. Okay? It's not wrong if it's this guy, but it's easier. My last step, divide everything by 3. Y equals negative 4/3 x. That's what this first part's telling me. Now, the second part, 6 divided by 3, gives me a 2 for that guy. Okay? Now, let's compare these guys. Okay? Remember, the slope is always next to the x. Okay? So the slope for this guy is negative 4/3. And the slope for this guy is also a negative 4/3. Therefore, these guys are parallel. Okay? They have the same slope. Look, the y-intercepts are different though, right? Isn't that what we talked about over here? Different y-intercepts. Okay? So if you have an equation, make sure it's in slope-intercept form, then compare them and see if they are parallel. And here's the cool part. You can graph them, and they should be parallel. Okay? All right. One more. I promise, one more. I know the video is about, 26 minutes. Well, you can do it. I know you can do it. One more example. Okay? So we have here y equals a half x plus 4, negative 2x plus 4y equals 12. Trust me, I have class in about 7 minutes, so I have to get this done. All right? Are these lines parallel, perpendicular, or neither? Now, the first one is written as slope-intercept form. Perfect. I don't want to touch that. The second one's not written in slope-intercept form. So I'm comparing like apples and oranges. Everyone loves saying that, right? That's a great saying. I want to put this in slope-intercept form first, then compare. To do that, I got to solve for y. My first step, I'm going to add 2x over to the other side. I have 4y equals, I'm going to put 2x out in front. It's positive, so it stays as positive. The 12's positive 2, so I'll just put a plus sign there. And then for my final step, I'm going to divide everything by 4. That way y can be by itself. Y is now going to equal the following. I'm going to reduce as I'm dividing over, okay? Let's look at the first one. 2 over 4. That fraction can reduce to a half. And x is next to it, right? Don't want to forget that. Now, 12 divided by 4 over here is a positive 3. Okay? Some people put like over 1. That means the same thing, but if you'd like to put as a fraction, we're talking a lot about slopes and everything's in fraction form, so it's no big deal, but I don't know if I would do that. Okay, now let's make a comparison. Remember, the slope's next to the x values. Okay, so the first one, we can see that it's a half for my slope. The second one is also a half. So I could say that these guys are parallel lines. Okay, that's it. I didn't mean for both examples to be parallel, to be perfectly honest. Let's change this. If this was a negative 2 over 1, one's positive, one's negative, that's the opposite part. If I take this and flip it, I get 2 over 1, which is the reciprocal. If this is what this ended up coming out to be, then it's no longer parallel. I can call them perpendicular lines. Okay? Big if that was the case. Okay? Okay, I promise that's it. All right, thank you for hanging in there. Hope you guys are doing well. My notes are uploaded. I have other examples, so if you need some more practice, they're there for you. Okay? And that's about it. So, until next time, I'll see you all in the next lesson video. Take care.